Good day everyone. In the previous lecture, we have briefly gone through the basic working of drones. However, what are the main components of a drone, or what does a drone comprise of, and how are the components actually helping the drone to perform its operations? This is the aim of our present lecture, where we will be doing an overview of the main components of the drone. Let's start with understanding the basic main components of the drone. The main components of the drone are propellers, motors, ESC, batteries, sensors, GPS, camera. These are the main components that build up a drone. There are many more components in a drone depending on an application. However, we will be looking at these components first to understand the basic buildup of a drone. Let's look at these components in much more detail. One of the most important parts of your drone are the propellers. These spinning blades are the wings to your craft, the very part that creates the airflow that lifts your machine into the air. Drone propellers come in many different shapes and sizes. They all serve the same overall purpose, but the flight characteristics of each can be dramatically different. The propeller on your drone is a wing. Actually, in the physics sense of things, it is multiple wings attached together. Spinning the little wings around in a circle creates the same air pressure, thus causing lift. The basic concept of a fixed blade propeller is that the faster the motor runs, the faster your propeller spins, and the more lift is created. Basically, more power is equal to more speed. There will be a theoretical maximum to this. Eventually, a propeller will spin faster than it can efficiently move air, but for the most part, we won't hit that with our consumer drones. The drone itself uses multiple propellers in pairs to create a balance. You have likely noticed that you'll have some rotate clockwise and others rotate counterclockwise. This is to help the drone itself from spinning out beneath the props. As a propeller spins, the force applied by the motor spins the propellers as much as it tried to spin the drone. The opposite side motor spinning the other direction creates a balance, preventing the drone from spinning so that most of that energy goes into the propellers. More about the propellers will be covered at a later part during the course. Another version of the propellers are folding props, which basically fold as shown in the figure. This is especially useful for making the propellers compact while transportation. There are two types of motors used in drones, brushed and brushless motors. They vary in the way they work. The brushless way are more powerful for their weight than brushed motors and they last way longer. For bigger quads, no question, brushless is king. When the motor windings become energized, both the motors have coils. A temporary magnetic field is created that repels and or attracts against the permanent magnets present inside the motor. This magnetic force is creating the repulsive force in the coil that is used to rotate the shaft. There are two major parts for a brushless motor called a stator and a rotor. The stator is the stationary part of the motor windings and the rotor is the rotary part of the motor, bell with magnets. Also, there are a lot of other minor things such as bearings, coils, magnets, shafts, etc. Brushless motors come in all shapes and sizes. The general rule of thumb is to aim for 2:1 thrust to weight ratio. More details about the motors, such as selection of motors and all, will be done at a later part in the course. An electronic speed control or ESC is an electronic circuit that controls and regulates the speed of an electric motor. It may also provide reversing of the motor and dynamic braking. ESC or electronic speed controller, this is what translates a pilot's control into precise instructions. sent to the motors to control movement. Multi-rotor aircraft are controlled by adjusting the speed of the motor and in turn the speed at which aircraft's propellers spin. It increases or decreases its height by increasing or decreasing motor speed. It flies forward by increasing the speed of the rear propellers and vice versa, and goes left by running the right hand propellers faster. Turns are achieved by taking advantage of the fact that two motors spin clockwise and two counterclockwise, and then precisely adjusting the speed of individual motor. The process of doing so starts with the aircraft's flight controller, which receives the pilot instructions, then translates them into digital commands which it sends to the ESC. The ESC, in turn, interprets these instructions and increases or decreases the voltage that to individual motor. When it comes to mini UAVs and micro UAVs and smaller format of UAVs, the most commonly method power are lithium ion batteries, configurations that power the electronic motors. Common requirements for UAV batteries include high energy to weight ratio, high discharge rates, 5 minute to 2 hour missions, resilience to shock and vibration, and fuel gauging to indicate remaining mission time. Battery packs are more than a simple configuration of cells. They are carefully engineered products with many safety features. The main components of a battery pack includes the cells, the primary energy source, the battery management system, a printed circuit board assembly that provides the intelligence of the system with features such as the fuel gauging and protection circuitry, the enclosure, either a plastic enclosure, plastic exoskeleton frame, or a shrink wrap PVC wrapper, and external contacts or connectors. The main consideration for batteries are battery life, battery composition, charging, and replacement cost. The current slide talks about the different range of sensors that are present on the drone. Accelerometers are used to determine position and orientation of a drone in flight, like a Nintendo Wii controller or your iPhone screen position. These small silicon-based sensors play a key role in maintaining flight control. MEMS accelerometers sense movement in several ways. One type of technology senses the micro movement of very small structures embedded in a small integrated circuit. The movement of these small diving boards changes the amount of electrical current moving through the structure, indicating a change of position relative to gravity. Inertial measurement units combined with GPS are critical for maintaining direction and flight paths. As drones become more autonomous, these are essential to maintain adherence to flight rules and air traffic control. Inertial measurement units combined with GPS are critical for maintaining direction and flight paths. As drones become more autonomous, these are essential to maintain adherence to flight rules and air traffic control. Inertial measurement units utilize multi-axis magnetometers that are in essence small, accurate compasses. These sense charges in direction and feed data into a central processor, which ultimately indicates direction, orientation, and speed. Grid sensors combined with gyros and accelerometer provide input to the flight control system in order to maintain level flight. This is extremely important for applications where stability is paramount, from surveillance to delivery of fragile goods. These type of sensors combine accelerometers and gyroscopes, allowing the detection of small variations of movement. It is a gyroscope compensation that allows these stealth sensors to be used in moving applications like motor vehicles or drones. In drones, power consumption and use are important. Current sensors can be used to monitor and optimize power drain, safe charging of internal batteries, and detect fault conditions with motors or other areas of the system. Electronic compasses provide critical directional information to inertial navigation and guidance system. Anisotropic, magnetoresistive, thermoalloy technology sensors, which have superior accuracy and response time characteristics while consuming significantly less power than alternative technology, are well suited to drone applications. Turnkey solutions provide drone manufacturers with quality data sensing in a very rugged and compact package. Flow sensors can be used to effectively monitor airflow into small gas engines used to power some drone varieties. These help the engine CPU determine the proper fuel to air ratio at a specified engine speed, which results in improved power and efficiency and reduced emissions. This provides basic view of the sensors that are used on the drones. With the help of GPS sensors, it is possible to estimate the exact location of the drone and perform predefined operations. Thanks to the use of these sensors, a route can be configured for autonomous flight. Configuring this route is as simple as drawing waypoints and curves on the maps. This technology is also used for commanding gimbal controls to point cameras to a fixed target. The use of high performance GPS sensors is essential for safe and precise operations. It permits to increase flight accuracy and permits automatic operations in low GPS signal locations. Dropping a GPS module into a drone made for an easy method to assist pilots with steady flight. Accurate global positioning wasn't just reported back to the remote, it helped navigate the drone. This is how most current drones hold a solid hover. They lock onto a fairly precise GPS position and fly themselves back to the spot if they drift out of place. Some drones have built-in cameras on board that allow the pilot to see where the drone is flying without having a direct line of sight to the device. Drone-mounted cameras help users see difficult to reach locations and can be a game-changing tool for first responders, especially in search and rescue scenarios. It provides a bird's eye view of the entire location. Cameras can be further used for capturing the video and performing algorithms on the video. They are important in terms of data collection and application. The current lecture intends to give you an overview of the main components of the drone. They are propellers, motors, ESC, battery, sensors, GPS, and camera. The selection and the physics behind these components will be further discussed in the upcoming chapters in the course. Similar to hardware, the software and the data also play a key component in the drones. The next lecture will focus on the software and data components of the drone. Thank you.